Welcome to Accounting Modeling. Today we are going to discuss about an important capability available in your spreadsheet package. We call it Excel Solver. We'll see what are the learning outcomes of this chapter. At the completion of this chapter, you should be able to explain what is Excel Solver. And also, we are going to discuss about several applications of this Excel Solver. The first application what we'll be discussing, we call it determining the optimal product mix. In fact, while you are in your second year, under the management accounting course, you have done the limiting factor analysis. So this is simply an extension of the limiting factor analysis. Then you are going to apply this solver for capital budgeting. Again, that is something which you had learned under your management accounting. So when it comes to several investment, so how to pick certain investment depending on the resources that you have. So it is another application that you are familiar with. The third application is scheduling the workforce. So when it comes to a particular organization, in a particular engagement, so we are going to see how to schedule that particular task. So how to schedule the workforce in that particular engagement. So the solver would help you with. And finally, we are going to discuss about how to apply this solver to schedule the transportation and the distribution of an organization. So these would be the applications what we would expect to discuss under this solver. Now let's see what is Excel Solver. Excel Solver is a tool that is available in your spreadsheet package which helps you to figure out what are the values that maximize or minimize a certain objective by satisfying several conditions. Say for an example, if you take a business organization, they may perceive the objective of maximizing the profit. Say that there's a business organization, they would be currently doing 4 products. Now when it comes to the resources that is available for this business organization, that is always in limited supply. Say it's material, say it's labor, these resources are limited. Then in the presence of these limited resources, how an organization would determine an optimum product mix in order to maximize the profit. In such kind of situation, you can make use of this solver tool and determine what should be the product mix when the resources are in limited supply in order to maximize the profit. So therefore, in such kind of situation, this solver may come into play. You can see that there is a certain objective, that is to maximize the profit, and also the certain constraints are there. The labor and material availability is limited. So those are basically the constraint. In the presence of these constraints, how you are to maximize the profit. And that is a particular scenario where you can make use of this solver tool. By using this solver tool, you can easily figure out what is the optimum product mix. If I am to take another example that you can think about, when it comes to the investment of an organization, initially they would look for alternative investment opportunities. Say that there are several investment opportunities are available. But When you are going to undertake this investment project, you can't accept all the project. That is mainly due to the resource constraint. The labor resources what you may have could be limited, and also the financial resources that you may have would be limited. So because of that, you cannot undertake all the viable investment. All the profitable investment you can't accept. So therefore, in such kind of situation, you need to decide what are the investment opportunities that will help to maximize the value of the business. And you should undertake those investment opportunities. So therefore, again, it's a kind of complex decision making scenario. So you, out of the many investment available, you need to pick what must be the most suitable investment. So in such kind of situation, you can see that your objective is to maximize the value of the business, that is in the sense maximize the NPV, and the limitations are there. The financial resources, the money is in limited supply, and also the labor is in limited supply. So the constraints are there. Then now you have to figure out what must be the kind of combination of investment that you are going to pick, or what are the investments that you are going to accept. So the Excel solver may come in handy in such kind of situation. Now let's see how to open this solver in your Excel. You can go to your Excel sheet. Then in order to open this particular capability, what you should do, you need to go to the File command. Then you can go to the Options. Then in the Options, you need to go to Add-ins. And once you click on these add-ins, you can see at the bottom, towards the bottom, the Manage. So there's a kind of drop-down menu available in front of this Manage icon. So once you click that, you can see that several options are there. In that, you need to select the Excel add-ins. In fact, by default, the Excel add-ins are there. Then you can click Go. Once you click that, you would be directed to this particular kind of dialog box, and there you can see the several options are available, like Analysis Toolpack, Analysis Toolpack VBA, Euro Currency Tools, likewise. So out of that, you need to take this solver add-ins. By default, the tick is there. The tick is not there. You're going to put that tick and you're going to say OK. And this is how you add that particular tool to your toolbox. In order to see where it is located, you can go to this Data tab. In the Data tab, under the Analysis section, you can see that the Solver button is there. The Solver button is there. You can simply click on that, then it gets open up. So this is the Solver tool. Now you have added the Solver tool to your toolbox. Now let's see how you can make use of this particular tool. So in order to learn that, so let me put it into a particular context, and with the application, we'll learn how to use this particular tool. So let me straight away start with the first application, determining the optimal product mix. The product mix problem involves determining the amount of each product that should be produced during a particular period to maximize profit. As I explained earlier, then the business organization, one of the important questions that they would come across, the management accountant would come across, determining the optimum product mix. This is especially the case when you are producing several products using the same set of resources, the same set of labor, material, likewise. The product mix problem usually adhere to the following constraint. The product mix can't use more resources than available, and there is limited demand for each product. So, in the context of determining the optimum product mix, you may have to do that subject to several constraints like the availability of resources, material, labor, likewise, and also the maximum demand conditions, the minimum demand conditions. So that is also some of the condition or the constraint that you need to take into account. So subject to several limitation, how you are to maximize the profit of an particular business organization, especially those who do several products. Let's take it through an activity. Activity 1. The ABC company produces 6 different types of product at its production plant. The production of each product require labor and raw materials as input. So they take two kind of main resources, the labor and material. The following information is given for each product. So you are given the unit price, variable cost, maximum demand, labor hours needed to produce 1 unit, and the kilograms of materials are given. Apart from that, you are given information about the labor hours that is available, and also the maximum availability of raw materials are given for a particular month. Then the requirement is to find the product mix which will maximize the company's profit. Then subject to these labor and raw material and other conditions and other constraints, you need to decide what is the optimum product mix for this ABC company. When you are approaching the question of this nature, we are into the model development. Hence, we always need to ensure that the input-output consideration. So therefore, first I might take this entire data because this serves as my inputs. So I might copy this and get them pasted. Right. So here I have the inputs. So you can apply your knowledge that you had gathered in your management accounting when you are working out the question of this nature. So this is basically the inputs that you have. And also certain inputs you might require to work out even. So when you are given the price and the variable cost, the most obvious information that you can work out is going to be the contribution per unit. So therefore I might add another information, that is contribution per unit. Contribution per unit. So it's just a matter of taking the unit price minus the variable cost. So it's 6 for A. Now you can simply drag it. Then the B, C, D, E, F, likewise it goes on. So now you had worked out contribution per unit. Then the most important thing, it's about your output. So your output, what is that? It is going to be your product mix. Product mix. So this is something what you are going to figure out. So this is going to be your output, the product mix. This is your output. Then at the moment, so I'm going to assume certain product mix. So I'm just going to assume certain products because that is something we are going to derive using our solver tool. So it is something that we are going to derive, but at the moment, so I might need to feed some product mix. So I would say that I might produce 100 units from A, 200 units. These are random numbers, right? 400 units, 520, 600, and 780. Likewise, I have just assumed several numbers. Then these are the information that is given. Variable cost are there. The unit price is there. So we work out the contribution per unit. Then the product mix was taken. Now I can work out the total contribution for this scenario. Total contribution can be worked out because I know the contribution per unit and also the product mix is given. So thereby I can work out total contribution. So when you come to the total contribution, one way that you can generate this answer, it's going to be like simply multiplying the contribution per unit by product mix, and thereafter you can add them together. So you might multiply this contribution per unit from the product mix and you get the contribution for each product. And if you drag this, it will give you the contribution for each product. And in order to get the total contribution, you can simply take the summation of this. And that is going to be your total contribution. So here we do not have any fixed cost being given. So that's why we worked out the total contribution. You can see that once you do so, that's 9,688. But here, as we always mention, when it comes to the model development, you need to uphold the basic principles of model development. That is, one of the consideration is efficiency. So here, when you are performing this total contribution, it seems that it is not something efficient. You simply multiply the contribution per unit by the product mix and thereby you manage to get this total contribution by adding. So therefore you had to do two steps. One is to multiply the contribution per unit by the product mix and thereafter take the total, and that is the process that you had followed. But here in this spreadsheet package, there is a particular function that is available to help you in instances where you have to do the multiplication and the addition. If you want to do it at a stretch, there's a particular function available and we call it, it is the sum product. It's the sum product function. In that, you can simply multiply and get the summation of the uh, columns or kind of rows. So here you can see that, so there are so you want to multiply the kind of rows, so therefore we take them as arrays. So first I would take this contribution array, so the contribution from A to F, you take that. Then I would take the corresponding other array that I want to get multiplied. So I want to multiply 6 by 100, 5.3 by 200 likewise. So therefore in the same order I might select it. Now what you are going to do, so this particular function will help you to multiply the arrays and get the total of that. So you can do that. These arrays, as far as these arrays are concerned, it can be located in kind of row wise or even column wise. But in this situation, what we have witnessed, the arrays are uh, situated like rows. So therefore we have taken the arrays which is located as rows. So you take you got 2 rows multiplied, then you get the answer. So here we get the same answer but using a kind of efficient way of doing. So that is the total contribution. So when you're working out the optimum product mix decision, so you need to follow these steps. So probably you may have to identify the contribution per unit, and also you need to identify the product mix, and you may have to work out the profit or sometimes the contribution. So therefore these are some of the steps that you would definitely have to go through when you are developing the model for product optimization. Now it's time to identify the constraint. So you would find that the constraints are there. So when you are going to do this, when you are going to maximize this contribution, you can't do that the way you wish it should do, subject to certain limitation, right? Now let's identify some the limiting factors of this scenario, or we call it constraints. We can identify the constraints. The question mentioned that the two explicit constraints are there. The first one is the labor availability, that is 4,500 hours, and the raw material availability. So let's take these two constraints. The first one is labor. It's labor hours. How many labor hours available with you? That is 4,500. So I would identify this as the availability. And also the material availability is also given. Material availability, material in kilograms, 1,600 material is available. So you must maximize this profit, maximize this contribution subject to these two explicit constraint, and also another constraint is there. It is about the maximum demand. Again, at any given point in time, you cannot exceed that maximum demand. So therefore it is also a kind of constraint. Now you need to work out another important thing. It's about the usage. So the availability you have identified, that is maximum 4,500 and 1,600. Now you need to identify, depending on your product mix, what is the usage of these labor hours and materials. Again, another important thing that you need to do, it's about the usage. So how do you get the usage of these labor hours at the moment? So at the moment, you have assumed the product mix of 100, 200 likewise. And also the labor hours needed per 1 unit is given. Then if you multiply this product mix by the labor hours needed to produce 1 unit, you would ended up getting this usage. So again, you can apply your knowledge, that is some product, you can get it. You can get them multiplied. The labor hours needed to produce 1 unit by the product mix. At the moment you have this product mix, that is the production. And then you can see at the moment 7430 usage is there. So it is big, depending on the random numbers what you have done. It is okay because this is something that we are going to work out. So at the moment we just identify the usage. Then you have the availability and the usage are there. Then if you are going to identify this constraint, how do you identify that? Your usage must be lower than or equal to the availability. Your usage must always be lower than or equal to this availability. So therefore, if I just write it, it should be something like this. Your availability is greater than the usage. That is the constraint. So I just mentioned that. That is it. That's it. Similarly, I might identify the usage of material. How I would do? Again, you can take this sum product. By using this sum product, you can take kilograms of material needed to produce 1 unit of product, and also you can get the product mix, then thereby the usage is there. At the moment it is greater than, it's fine, it's perfectly fine, because that is something we are going to figure out. So you can see again the availability must be greater than or equal to this usage. Availability should always be equal to the usage, or it must be greater than, or otherwise the usage must be lower than the availability. Okay, now we have uh, done the model. Now we can identify the answer for this with the help of solver. Now what you want to do, with the support of this solver, you want to figure out what is the optimum product mix. What is the optimum product mix subject to 3 constraints: the labor, material, and also maximum demand. Let's see how to do that. I might go to this data and I might take this solver. So once you open it up, you can see that the very first thing what you need to do is you need to set the objective. What is your objective in this particular business scenario? You want to maximize the total contribution. That is your purpose. That's why you are looking for an optimal product mix. So therefore your objective is to maximize the profit or the contribution. So therefore you are going to set your objective by clicking on this. You can select the total contribution. Total contribution. And what you want to do with that, you can either maximize, minimize, or even you can take that equal to a particular value. But out of these options, here we want to maximize the profit. So we mention what is the objective. Then it asks, what is the changing variables? By changing what, you are going to maximize the profit. By changing what, you are going to maximize the profit. By changing the product mix. By changing the product mix is how you're going to achieve this contribution or maximize this contribution. So therefore your changing variable is going to be what you are going to search for. In this business scenario, you are searching for a optimum product mix. So therefore you are going to say that by changing this product mix, you are going to maximize the profit. So therefore your changing variable is going to be this product mix. So you select it. So it's quite straightforward. It asks you several questions. You are going to answer that. The first, it asks you what is the objective. You specify that you want to maximize the total contribution. Then how you are going to do that? By changing the product mix. Then it asks what are the constraints that is there. So this is applied in a kind of situation where there are some constraints. So then it asks you what are the constraints. Then what you can do, you can simply add the constraints. So you can click on add. Once you click on add, you can add this constraint one by one. The first constraint, what is that? The first constraint is that you need to give that cell reference. The first thing, you can see that your labor hours, there's a limitation. The maximum is 4,500, right? So therefore your usage must be less than or equal to the constraint. So therefore you are going to set the constraint in this side and the respective usage in the other side, right? So therefore I might select the usage of the labor in this given business scenario must be, you have several options. Out of that we want the usage must be less than or equal. The usage must be less than or equal to what? The constraint, that is 4,500. Here I must say that this sign is not have any impact on this entire scenario. So here I have just mentioned this sign, that is to ensure myself that I'm getting this constraint correct. So therefore you need not to worry about this particular sign what I have put over here. So if you put this usage this side, availability the other side, it's not going to make any difference. This is just to convince myself. So how to enter this constraint perfectly? I have done this particular activity, right? So otherwise you would try to memorize that. In a situation like this, you always need to put the availability somewhere over here, then the usage over here, and put this greater than or less than sign. There's no any rule on that, but the most important thing is you identify the availability and usage. Then everything depends on how you feed that particular, or how you feed that particular piece of information to this constraint. That is the most important thing, right? Here you enter always the cell reference. The constraint comes on this side. So therefore in my case, the constraint was the labor hours. So I have taken that. Then if the constraint is that, I need to make sure that the usage should comes over here. So therefore the usage must be lower than or equal to the availability, right? That's the thing. So therefore there is no hard and fast rule in taking this usage and availability. You can take it to the different sides. It doesn't make any difference. The what matters is you identify them correctly. තොර පුතාලා අපි මේ මොඩල් එක ඩිවලොප් කර ගැනීමේදී මම constraint අඳුනගත්තා. ඒතකොට මේ constraint අඳුනගද්දී මම පොඩි ස්පේස් එකක් තියලා අඳුනගත්තේ මැදින් එක row එකක් එක column එකක් ඉතුරු කරලා. ඒතකොට මේ column එකේ මම පොඩ්ඩක් mention කරගත්තා මේ වගේ දෙයක් තමයි සිද්ධ වෙන්න ඕන කියලා. ඒතකොට මොකක්ද availability එක සෑම වෙලාවකම වැඩි වෙන්න ඕන usage එකට වඩා. එහෙම නැත්නම් අනිත් පැත්තට අපි කිව්වොත් usage එක සෑම වෙලාවකම availability එකට වඩා අඩු වෙන්න ඕන. ඒක තමයි යථාර්ථය නේ. අපිට තියෙනවට වඩා වැඩියෙන් use කරන්න බැහැනේ. So අපි question එකේ ensure කරන්න ඕන දෙයක්. දැන් මෙතන ඒක වැඩි වෙලා තියෙනවා. ඒක හේතුව තමයි අපි randomly තමයි numbers දැම්මේ. නමුත් දැන් අපි මොකද්ද කරන්න යන්නේ මේ constraints වලට යටත්ව මේක මේ අපේ total contribution එක maximize කරන්න තමයි උත්සාහ කරන්නේ. අපිට පෙනෙයි අපි මේ solve එක run කරපුවාම මේ usage figures වෙනස් වෙනවා, මේ product mix එක වෙනස් වෙනවා, contribution වෙනස් වෙනවා. එතකොට අවසාන වශයෙන් අපිට එන උත්තරේ මේ constraint සියල්ලම satisfy වෙච්ච තත්වයක් තුල profit එක maximize වීමක් තමයි සිද්ධ වෙන්නේ. right? එතකොට මෙතනදී වැදගත්ම කාරණාව තමයි අපි constraint අඳුනා ගැනීමත් ඒ අදාළ availability හා usage එක අඳුනා ගැනීමත් තමයි වැදගත්ම දේ. ඒ වගේම තමයි usage එක හඳුනා ගැනීමේදී ensure කරන්න අපි some product function එක use කරලා එක කරන්නේ. මොකද මේවට links create කරලා දෙන්න ඕනේ. මොකද solver tool එක මේ තියෙන mathematical relationship එක තමයි යන්නේ. නිසා මේවා සෑම වෙලාවක usage එක ad hoc විදියට work out කරන්න එපා. ඒවා දාල proper cell references වලින් අරගන්න ඕන කියන කාරණාව මතක තියාගන්න. එතකොට අපි ඒක ensure කරා total contribution එක ගනිද්දිත් ඒ වගේම මේ usage එක work out කරද්දිත් අපි සෑම වෙලාවකම ensure කරා මේ දේවල් ගන්නේ proper relationship maintain වෙන විදියට. ඒත් එක්කම contribution per unit එකත් අපි work out කරේ ඒ ආකාරයෙන්. right? Those aspects need to be remembered. right? Okay, now we have at the first constraint, it's about labor. So add it. Now the second constraint, it's about the material. Again, you need to ensure that the material usage must be less than or equal to the constraint. Less than or equal to the constraint. That is the second one. You ensure that. Then I told you that there's another constraint. What is that? That is, at any given point in time, this product mix should not exceed the maximum demand. So therefore, what you can do, you can select this product mix. The entire range can be selected and it should be less than or equal to what? To this corresponding cell range. That is maximum demand. It must be less than or equal to this maximum demand. That is our third constraint. So we have identified 3 constraints. I might click add. Thereafter, there would be another constraint. What that particular constraint? In most of the questions, it might make explicitly, but in some cases it might not mention. But that is your common sense. Using your common sense, you must be able to identify that particular constraint. And we call it, that is a constraint. You know, when it comes to these units, you can't have fractions. Fractions of units can't be there. So therefore, that is also a kind of constraint. The fractions cannot be there. So therefore, you need to mention that the product mix must consist of what you call the completed units. The product mix should comprise of completed unit. Then how do you ensure that? You can select this product mix and you can say that the product mix should be integer. It must be integer values. So then it get it as the completed units. So if you take that, int would stand for integer. So you would take this integer. See, that's it. So then you have ensured that, so all the product mix that you get, so it consists of completed units. So in this situation, altogether we have add 4 constraints. So it was explicit only 2 constraints, but using our common sense, we identified 2 more constraints. So it is applicable for this product mix scenarios. So therefore, that is something you can remember. So the labor was one constraint, and then you have this material, another constraint, and Then you ensure that this product mix should not exceed the maximum demand, and also you ensure that this product mix should consist of completed units, so therefore it's an integer. And then you need to ensure this particular tick which is available here is there. By default it is there, and it says that make unconstrained variables non-negative. So it is called the non-negative principle. You need to make sure that the negative numbers are not involved. In this particular scenario, negative numbers are not involved. So that's why it says make unconstrained variables non-negative. You would by default you would keep that, and then you need to select a solving method. So your solving method, you have different options. You can assume a kind of non-linear relationship, or it's a kind of linear relationship. But here what we are going to assume, that we are assuming between these independent and dependent variables there is a linear relationship. There's a linear relationship is what we're going to assume. So therefore it is recommended in almost all the cases select this solving method as simple LP. It's assume a linear relationship. It assume a linear relationship. You can see that you can further read on this solving method. Select the nonlinear engine for solving problems that are smooth nonlinear. Select the LP simplex engine for linear solve problems, and select the evolutionary engine for solve problems that are non-smooth. So out of these different kinds of relationships, we are going to assume that among the dependent and independent variables, you would have this simple linear relationship. Simple linear relationship. So in this particular case, we know the dependent variable, that is going to be the total contribution. It depends on the product mix. So the product mix is going to be the independent variable. So among the total contribution and product mix, there is a simple linear relationship exists. Simple linear relationship exists. Then apart from that, there are certain other options are available. I would take some of them. You can see that there's option available for change. It is in fact the edit one. Say that if you want to edit a particular constraint, you can simply select that particular constraint and you can click on this change. Then you will be taking to this change constraint. So you can do whatever the change that you need to do, and thereafter you can get the, you can say OK. So here you can cancel that. We haven't made any changes. So if you want to make any change, that must be the way. Having added that, if you find that something is wrong, you can go and change it. So whatever the change that you want to do, and do that and say OK. So here, since we have added everything perfectly, I'm not going to change that. Then the delete, it is straightforward. If you want to delete a particular constraint, you can simply select that and delete it. And if you click on reset, so what happens is all these things going to get vanished, right? You're going to do it from the very beginning. Everything would get erased, the constraints and even these changing variables and the objective. So those would be erased. And thereafter you can, if you want to save this, you can take this save option as well. Then having done this, what we need to do next, it's about solving the kind of business scenario. Now you can solve it. So let's say if check everything is perfect. You have set the objective, that is to maximize the total contribution, and then you take this changing variable, it is the product mix, and then you have taken this constraint, the labor constraint, material constraint, and also the maximum demand, and also the integer one. You have taken everything, then you can say solve. So once you click that, you can see two important things are there. So it will ask you, so once you solve this, do you want to keep this solver solution? So in fact, that's what we want to do. So we want to keep the solver solution. So here you can see, once you click that, here the answer has come. So once you click solve, it has solved. So at the moment you can see that your product mix has changed. Your product mix has changed, the contribution has changed, and also you have satisfied all the constraints. See, now your usage is equal to the availability. The material usage is less than the availability. So it's fine. And also if you check with this product mix and the maximum demand, that's also perfectly fine. So you haven't exceeded the maximum demand in any instance. Hence, you have satisfied all the constraints. Then also these figures are complete units. Completed units are there. So therefore those are integer values. Hence, it has satisfied all the constraint, and subject to that, it has given you the optimum product mix. So therefore, in a situation like this, you should produce 2 units from C, 594 units from D, and 1084 units from E. That is your optimum product mix. Then it asks you, do you want to keep this original answer? Do you want to keep this solver solution, or you want to still keep the original value which we have entered earlier? So obviously we want to keep the solver solution, and that's what we are looking for. And on the other side, you can see that the report is there. You can see the answer report. If you want to take a kind of report of this, you can get that. And it is recommended to take a report on this, right? You may select that. So keep solver solution and the answer. Then you can say OK. Click OK. So the answer would remain, it has satisfied all the constraints. And also if you go to the answer report, you can see the answer report has been generated. That says this is your objective. So you can remember that the objective is what you had set first. So depending on the scenario that you had created, there was a kind of value, that was the total contribution what we had witnessed earlier. It was 9688. But once you run this solver, it has come to this figure, that is 6624.8. So that is the final value, satisfying or subject to all the constraint, that is the value that you would get. Then also the variable cells are given, that is about the changing variables. Changing variables. Originally we have assumed certain numbers, and in the original column you can see that is there. Its original value, it's 100, 200, 400. Likewise, we have just feed them. But once you run this solver, so this would be the combination of product that would satisfy all the given constraint. That would satisfy all the given constraint. So that would be the final value. And also those are integer values. Then you come to the constraint. You have set several constraints, and there they identify that the first constraint is the labor constraint. You can see in the labor constraint, so you have used almost all the labor. So if you go to the answer, you can see 4500 was the availability, and in fact you have used this 4500. So therefore it says that it's a kind of binding constraint. What do you mean by this binding constraint? That means that is the constraint which will hinder your profit potential. So which will kind of constraint that prevent you from achieving a maximum profit. So you are really in short of this. If you have some labor available, you could have gone for a kind of greater profit. But here the labor availability was 4,500 and you have used it to the fullest. So therefore it's a kind of binding constraint. So it's a constraint that will hinder your profit potential. So therefore it is called binding. But if you look at the second constraint, it's about the material. It says that it is not a binding constraint because there is a slack available. Slack available. What is that? So the availability of this material is 1600. So depending on this scenario, all what you had utilized is 1237. So therefore that is not a kind of critical constraint for you because you have some additional. In fact, there's 363 units, additional units are there in material. So it is basically not a kind of constraint that will hinder your profit potential. So even if you can change the other variables, so still the material, some material would be available. So අපි මේ කතා කරනවා වැදගත් කාරණාවක් මොකක්ද මේ constraints වලට ආවම සමහර constraint අපි කියනවා binding constraint කියලා සමහර ඒවා අපි කියනවා non binding කියලා. මොකක්ද මේ binding සහ non binding කියන්නේ? ඒතර binding constraint එකක් කියලා අපි කියන්නේ ඒ constraint එක තමයි අපේ profit potential එකට අපිට යන්න තියෙන දැනට තියෙන critical ම බාධකයක්. දැන් අපි ලේබර් ගත්තොත් ලේබර් අපිට ගොඩක් ක්‍රිටිකල් වෙනවා. ඒතකොට ලේබර් අපිට available වෙන්නේ 4500යි. අපි 4500ම යූස් කරලා. එතකොට අපිට තව දුරටත් අපේ ප්‍රොඩක්ෂන් වැඩි කරන්න පුළුවන් කමක් නැහැ. ඒ නිසා අපේ ප්‍රොෆිට් එක ලිමිට් වෙලා තියෙනවා. හැබැයි මැටීරියල් ගත්තොත් එහෙම තත්ත්වයක් නැහැ. අපි 1600ක් තිබ්බා available වෙනවා. නමුත් ඒකෙන් යූස් කරේ 1237යි. නිසා අපිට අවශ්‍ය නම් තව මැටීරියල් තියෙනවා. නිසා ඒක බයින්ඩින් නැහැ. ඒක non binding. නමුත් labor it's binding. It's a critical constraint. ඒ නිසා අපේ profit potential එක තව දුරටත් වැඩි කර ගැනීමේ හැකියාවක් අපිට නැහැ. Similarly, there would be some other binding constraints as well. So we don't have, depending on this constraint altogether, even this product mix, the product A, B and C, those are some binding constraints. So depending on the resource availability, we cannot maximize, so we cannot increase the number of units that must be produced. So therefore it says it's a kind of binding. And when it comes to this product D, it says that it's not binding because we have the potential even to produce one more unit. So if you look at this D, so depending on the resources, so there we can go for even one more unit. So therefore it says it's non-binding. And again the product E, it is binding. So why is that? Because the maximum you can go is like 1084 and you have already gone for that. So therefore it has a kind of binding variable. So if you had more resources, you would have definitely gone for this. Even if you do not have this maximum demand constraint, you would have probably gone higher than this 1084 unit. Hence it is binding constraint. And it must be seen in the context, so considering all the other aspects. And also product F, that is not binding. It's not binding. So it is says that even the slack of 1 unit. So if you you can even expand for one more unit, but depending on the other resource constraint and the other constraint in terms of the maximum demand and also the integer situation. So it has kind of non-binding. So out of these constraint, what must be the most important consideration? That would be the labor and material, and those are the things that we had explicitly identified. And also the maximum demand is also kind of important constraint. So likewise, you must be able to kind of make some sense out of this report. So I just try to make some sense out of this one. So how to read this objective, variable cells, and binding and non-binding constraint. So when it comes to that binding and non-binding constraint, the sum of the things are quite straightforward to make some sense, while some of them are not that much of straightforward. So like when it comes to labor and this what do you call this material, those are quite straightforward. And even this product E, so making some sense out of that is quite straightforward. But the rest of the things, so it was little bit gray, because here it consider the combined effect of this constraint, and depending on that, the system is going to say that it is binding or not binding. So therefore, it is something that we cannot straightforward in a straightforward way say that how it has become binding or non-binding. But still, if you can make some sense out of that, so like several variables that you can clearly make sense, and that would be good enough. Right. So it's about the first activity. Now let's move on to the activity. Here it explains how you must do that. So in fact, we have tried this out. I have taken you through all of this. You can simply read that. And here it explains that the constraint of non-negativity. So there we have applied that. In that, I haven't deliberated much on that. The constraint of non-negativity means if the results of changing cell must be non-negative, do the following. So the changing cells, if you want to make sure that it is non-negative, and you can select that non-negative uh, constraint. So that's why we kept that tick box. Then let's look at the activity 2. We'll see, find the solution for the following question based on the model developed in activity 1. So you are given several questions. In fact, there are like 1, 2, 3, 4, 5, 6, 7 questions are there. So you can take those questions, and we'll try to figure out the answer for that. So I must paste it. We may keep some space. So better we take questions. I may take it somewhere down. Then we can have some space by inserting the cells. Probably some space is needed. I'm simply trying to maintain that. Right. Now let's see question one by one. Which product is more profitable? It asks us, so depending on this situation, which product is more profitable? So it's quite straightforward. So it is the product that you had produced the most. So here you can see that out of this given product, you had produced product E the most. Product E the most. So therefore, obviously, product E is going to be the most profitable product. And you have given the priority for product E, and you have gone for the maximum number that you can do. And thereafter, depending on the remaining resources, you have tried out rest of the product. So therefore, the most profitable product is going to be product E. So that is straightforward. Then it asks you, if the fraction of product cannot be produced, what is the optimum mix and its profit? In fact, that's what we have already done in the when we are working out the question, the first activity. There we assume that particular situation. So therefore, it has already there. This would be the product mix. So we have already taken that. If the minimum production of product A, B, and C is 50 units for each product, what is the new optimal mix of its profit? Then it introduces another constraint. What is that? At the moment, you can see that you are not producing that much of units from product A, B, and C. In fact, from A0, B0, and C2. So that is your situation at the moment. I might paste that. So I forget to take one. And also let me take the product as well in answering the question. Second one. Then it asks third one, if the minimum production of product A, B, and C is 50 units for each product, what is the new optimum mix and its profit? So then it suggests it's another kind of constraint. So let us add that particular constraint as well, and then we see. It is the minimum kind of minimum demand or minimum production, I would say. It's minimum production. So what is the minimum production? It's going to be that product A, product B, and C, you have identified the minimum requirement. It's 50 unit each, 50, 50, 50. So that serves as your fifth constraint. Now, depending on that, we may try to figure out what is the optimum product mix. Now let's get that. All what we have to do is you can simply go to the solver that you have taken, and you need to simply modify that and add a constraint. And what that constraint? It is the minimum requirement. You need to ensure that one thing. What is that? Your product mix, when it comes to product mix, A, B, and C, here we have this A, B, and C. A, B, and C should be greater than or equal. In minimum, you need to produce 50. So therefore, it should be greater than or equal this. In minimum, 50 units has to be produced. So you add the constraint, and that is your fifth constraint. What you did, you went to the product mix and you select the first three products first three products A, B and C, that is from B10 to D10. එතකොට අපි කොහොමද කරේ එක? මුලින්ම අපි product mix එකට ගිහිල්ලා select කරා ABC කියන cells ටික. ඒ ටික අපි කිව්වා greater or equal වෙන්න ඕන කියලා constraint එකට. That's it. Say okay. You have added that constraint, then you can solve it. So click solve, and you can ask to keep the solver solution. You would see that, and also we may ask for an answer report. Depending on the new condition, we may ask for an answer report. Another report would be given, that is your answer report 2. Say okay. Right. Now see what has happened. So it has made that particular change, and they have made sure that now your product mix consists minimum 50 product is produced for A, B and C, and the rest of the products being produced together. So that's what has happened once you add the fifth constraint. Now you have satisfied that. By satisfying that, what is the total contribution now? It's 6,409. Now you can even go to the answer report 2. You can see the original situation was this 6,624, but now you have 6,409.8. that is the total contribution, and also you are changing variables. Values were these original values, and before this constraint being added, this was the value, but after the constraint being added, and this is the final values. And also the binding and non-binding consideration is there. Still you can see 4,500 labor being fully used, so therefore it's a binding constraint. But the usage of material, it's not a binding constraint, so it is clearly mentioned not binding. And here you can see that the binding constraint, this minimum requirement, it has taken as a kind of binding constraint there. And also you can see that another binding constraint, that's going to be this 1084. You can see that you have produced that to the fullest. You have produced that to the fullest. So therefore the maximum demand would serve as a kind of constraint. And yeah, so that's it. Now we can take this answer for a question. The question asks you, the minimum production is A, B and C is 50 units. What is the new optimal mix? So this is an optimal mix for each of the products. That is a combination. Then it asks, what is the shadow price of a labor hour? Shadow price of labor hour. What is that? What do you mean by shadow price? Shadow price means that what is the maximum price that you are ready to pay in order to acquire 1 unit of the specified resource. Specified resource, especially it is a binding constraint. අපිට මේ question එකේ දැක්කා labor කියන්නේ binding constraint එකක්. එතකොට shadow price of labor hour කියන්නේ labor hour එකක් අපි දැන් මිලට ගන්නවා නම් වැඩිපුර labor hour එකක් දැන් අපි මිලට ගත්තොත් අපි මේ labor hour එක වෙනුවෙන් ගෙවන්න කැමති උපරිම මිල. That's what the shadow price means. If you purchase 1 more unit of a binding constraint, here it is labor. If you purchase 1 unit of labor, what is the maximum price that you would ready to pay for this labor hour? And that is called the shadow price. Now let's see here what it says, how you can get the answer for this. What you can do, you can increase the labor availability by 1 unit. And let's run this and see what is the change that it's going to bring to the contribution. Remember, at the moment contribution is, I might take it somewhere over here, 6409.8. that is the existing contribution. तर අපිට මේ දැනට තියෙන තත්ත්වය තුළ contribution එක පේනවා 6409.8ක් තියෙන්නේ. අපි දැන් බලමු labor hours එක unit එකක් වැඩි කරලා. Let's increase the labor hours by 1 unit. Let's make it 4501. Right? Then run the solver again. So having changed that, you can ask the solver to run. We do not get this answer report because there would be many more. So therefore just ask to keep the solver solution. See what has happened. If you increase the labor by 1 unit, you can see the new contribution is different from the previous one. So now you have 6411.6. That is simply because if you increase your contribution by 1 unit, and this is what it's going to happen. So therefore, under this circumstance, depending on the constraint that are being given, in maximum, you are ready to pay rupees 1.8 per 1 labor. So that is the maximum contribution it gives. So obviously, that would be the maximum price that you would ready to pay. So definitely it should be something less than that because you want to make a profit. But if you set the maximum ceiling, in order to acquire 1 unit of labor, you would ready to pay only rupees 1.8. Rupees 1.8. And that is your labor or shadow price of labor. So you can take it rupees 1.8. It's rupees 1.8. Then it asks, what is the product mix to get the expected profit of 5,000? If you are to get the profit of profit of 5,000, what must be the product mix? Then this time what you want to change? It talks about a certain profit that you want to achieve. So therefore, this time you're going to change your objective. So at the moment your objective is there, that is B12. You want to make it equal to a particular value, and that value is 5,000. You want to make it equal to 5,000. Then you can say solve. Keep solver solution, say okay. See, if you are to make a contribution of 5,000, this should be your product mix. See, it is different from what you had taken earlier. So your product mix is now, this is it. So your product mix is now different. Then the next question asks you, if the fixed cost is 1,500, what is the optimum product mix and its profit? It asks, if the fixed cost is being introduced, what is your optimum mix and its profit? Okay. Then we might need to expand our model. So here the total contribution is there. Now we are going to introduce fixed cost. So if you introduce fixed cost, it says that it is 1,500. You know the profit comes once you take this fixed cost deducted from the total contribution. Total contribution is there. You take the fixed cost and there it comes the profit. Then the question asks you, what is the new profit and what is the new product mix? Hence this time you are going to change your objective. Your objective is going to get changed. Go to data, solver. It's no longer B12, but it's now B14. You can select that. Yeah, you have replaced it. And what you want to do, you do not want to make it equal to a certain value, but you want to maximize the profit. So take it max. The same changing variable, same constraint, and say solve. Keep solve a solution, say OK. See, this is it. Your profit comes as 4911.6, and this would be your product mix. Your product mix is like this, and then it asks you what is the profit. That's 4911.6. that is your profit. That is the optimum profit. So it doesn't come. You can simply type it 4911.6. Then finally it asks you if the availability of labor hours have been increased by 500, what is the optimum profit? Then when the things are like this, it asks you if the labor hours get increased by 500, what is the optimum profit? At the moment, we have keep that in 4501. So let's add another 500 to this, then see how much is going to be our profit. If you increase it by 500, let's see what is the profit. So it become 5001 availability. Once you add 500 to that, and again you need to run this solver for the updated situation. Profit need to be maximized, the things as such, say solve, and you can ask to keep the answer. So it's going to be 5611.2. New profit situation is 5611.2. What is the optimum profit? And you can get that particular profit. You can copy that 5611.2. That is your optimum profit. That is your optimum profit. So likewise, what you have learned over here, that so once you develop the basic model, for the changing circumstances, you can simply keep accommodating that in the basic model what you had developed. So that is the most important learning outcome. Hence, you are working out a question where you have to optimize the product mix. Remember, you need to first develop this structure. Most importantly, you would identify the contribution per unit. Then the product mix is going to get identified. The total contribution, if the fixed cost is available, fixed cost, and thereby the profit. And most importantly, constraint should also be identified. And that is how you approach a question of this nature.